Hey folks, my name is Ray Lojano, and this is the tutorial section of Kubernetes Essentials, which is my talk that was delivered at DevWeek 2024 in Oakland, California. So I'm going to walk you through the tutorial section on a Mac OS. This is on Apple Silicon Mac. So with this tutorial, we will create a local Kubernetes cluster. We will use Minikube. We'll install the prereqs, which is Docker, then Minikube. Then we will create a Minikube cluster. Then we will explore the cluster a little bit. Then we will deploy a containerized application in a pod. Then we'll also deploy the same application, but an older version of it in a deployment. And then we will update the application in that deployment. We'll also scale it up and down. Then we will expose the application with the service. Then we will do some cleanup. So the first step here, we will need to look at the prereqs here. I'm going to minimize the screen here. So first off, we need a local Kubernetes cluster. We will use Minikube. In this example here, you could use Kind, you could use K3D or K3S as well. So with Minikube, there are some minimum requirements here. You can take a look at 2 CPUs, 2 gigs of memory, and 20 gigs of disk. You probably don't need 20 gigs of disk and an internet connection. We do need to install Docker in this case, since I am on a Mac OS. I'm going to use brew to install Docker, brew, install cask Docker. And this will take a few minutes here, so we'll wait and give it some time. Meantime, after this installs, we will open up the Docker application. This will require my password to continue. Docker is installed. So let's open the Docker desktop application. And this will bring up the GUI for Docker Desktop. I'm going to select open for this. And what we want to have is Docker running. And reapply configurations because I've reinstalled this several times. So Docker engine is running. I'm going to minimize this for now. So next, we will install Minikube, and we could also use Homebrew to install Minikube on Mac OS. And there's links and also instructions on depending on what OS and architecture you are running to install both Docker and Minikube as well. So once Minikube is up running, we'll go to the next step is let's create a Minikube cluster with Minikube start. Let me clear this up. And with Minikube, we will use kubectl that's bundled in with Minikube. So let's run. And to do that, we will use Minikube prefix the kubectl command with Minikube is kubectl get nodes. And I've already used Minikube here, so it's already already have a kubectl already installed for Minikube. But if it's your first time, you might see in the little different output that it will download the right kubectl bundled in with Minikube for your OS and your architecture. So let's go ahead and explore the cluster a little bit. So we could go to Minikube kubectl get pods. And since we did not include a namespace, it will use the default namespace. So let's take a look at what namespaces are available. But first, I'm going to clear this up a little bit. Minikube, kubectl. Yeah, namespaces. Notice here I did put a little hyphen. Typically, let's try what we would typically do with kubectl, minikube, kubectl, get pods. For all namespaces, we will give the option all namespaces. And we see that it's an unknown flag here. So with the kubectl with minikube, we have to do the format is minikube kubectl dash, then get pods on namespaces. So with the additional option, so of course kubectl, with the additional option, we have to add dash right after kubectl. So we could see some of the control plane components of this local cluster: etcd, core DNS, API server, controller manager, and the scheduler. So let's deploy a containerized application pod. In this case, we will first create a namespace for our application. So we'll use minikube kubectl, create namespace, my namespace. We didn't use an additional option. We could just go ahead and do minikube kubectl create. Namespace has created. Next, we'll we'll create a pod. We're going to do it first in an imperative way. An imperative way, meaning that we are using a command to create this pod here. I'm going to just copy this for now, just to make sure I have everything in my terminal. So minikube kubectl run Nginx, so that will run a pod. We're going to call the pod Nginx. We're going to use the image Nginx with the tag 1.25.4 in our namespace that we just created, which is called my namespace, and we're going to expose port 80 on that pod. So now the pod has been created, and we can get the virtual IP of the pod if you want. Remember, every pod in Kubernetes receives a virtual IP. So we see it's 10.244.0.3. Yours might be different, by the way. I'm going to expand this a little bit so we can see more of the commands here. Next, let's take a look at the logs of this pod that we've created and clear this up using minikube and kubectl logs and the pod name Nginx and the namespace my namespace. So we can see these are the logs, are what's in standard out for our container and the pod. If you have multiple containers in the pod, you do have to specify which container you want to get the logs for with the -c option here. So here we see we are running Nginx 1.24.25.4. Let's go on to the next steps here. So let's now delete this pod. We're going to create this pod again in a declarative way. But first, let's delete this pod. And kubectl delete pod Nginx in the Nginx or in the my namespace. This time we're using the shortened version of the option with just -n. And we have deleted the pod. So, like I said, the first way we deployed the pod was the imperative way. So now we typically folks deploy to Kubernetes with manifests, which is called the declarative way. So we're stating the states we want our resource to be in running in Kubernetes with a manifest. So now let's deploy this pod in a declared way. We're going to create a manifest for this Nginx pod, and we're going to use HereDoc to create that file. And just to review here, with this pod manifest here, we are giving it the name Nginx in the my namespace, and we're giving the label app equals Nginx. We're naming the first container, it's the first and only container, Nginx, and with the image version 1.25.4 for the Nginx container image, and exposing port 80. So now we're going to use the apply command. So minikube kubectl apply -f, and we're going to point it to the pod manifest here. So minikube kubectl apply -f pod.yaml. So now our Nginx pod has been created. And once again, we could take a look to see what the status of this pod is. Minikube kubectl get pods in the my namespace and -o wide. So we see our pod is running. Same virtual IP 10.2.4.0.4. Now let's delete this pod because we're going to deploy this application or this Nginx application, and now in a deployment. So let's delete the pod. Minikube kubectl delete pod Nginx. Let's clear this up before we go on to the next step. So let's create a manifest for our deployment, and we're going to create the manifest so that it has two replicas of the same pod using an older version of the Nginx container image. So we will copy this here. Let me just press the copy command. So this is a deployment. The name Nginx and the my namespace. We're giving the labels app equals Nginx. And for the deployment spec, we're just saying that we want two replicas. And for the pod template, we're giving the label app equals Nginx, which has to match the label selector for the deployment app equals Nginx. The pod template has a pod spec with the container, only one container. We're naming Nginx, and we're using 1.25.1. and with the container port, port 80. And next, we're going to use kubectl apply again to start this deployment. All right, our deployment is running. So now let's take a look at all the resources. So there's a command kubectl get all. It doesn't actually get all the resources, but it gets the main resources: the deployment, the replica set, and the pod. Let's clear this up first. And kubectl get all, and within the my namespace. And we can see here we have our deployment called Nginx, and we had two replicas of that. So this deployment create this replica set, and this replica set manages these two pods here. So we're going to do kubectl describe to describe the deployment. Using minikube kubectl -s describe deployment Nginx and the -n my namespace. I'm going to take a look at a few things here. First, I want to note the old replica set is none right now, and the new replica set matches our replica set that we have. Also, make a note of the other fields as well, like the rolling strategy, as well, 25% unavailable, and 25% max surge. We could see the events as well. Now we're going to do the same thing, but with the replica set. And we're going to use the JSON path here to get the name of the replica set. Clear this up. So minikube kubectl describe rs for replica set, and we're going to use the kubectl get rs and command with the JSON path to get the name of it, since the name has a hash as a suffix. So here we could take a look to see what the pod template is, as we see if we compare it to the pod names that is controlled by this replica set. So now let's update this application, and we're going to do it in an imperative way instead of a declarative way. Just to make it a little bit easier, so we're going to do minikube kubectl set image command to update the image for the deployment of the Nginx deployment and the Nginx container of that are in that deployment. We're going to use Nginx 1.25.4 and in the my namespace. So as that is done, we want to, if you do this quickly, I may not have. Next step is to do get all as well. So it looks like it was a little too fast for me. You can see 8 seconds and 9 seconds here, but it looks like, so these are new pods here. This is also, we see our old replica set, 2 minutes old, and our new replica set is 9 seconds old. And the existing pods is controlled by that new replica set. Take a look at the hash of the replica set here. I'm going to describe the deployment once again. When minikube kubectl describe deployment, Nginx, the my namespace namespace. Now let's take a look at the old replica set. So that's our old replica set, and now we have a new replica set that was updated. We can also see the events as well that we just did to update the application image. You can see the image is updated as well. So now let's scale the deployment. Let's say if your application has more users and you want to increase the number of replica pods of your deployment, we could do it in an imperative way. You could also do it in multiple ways with a declarative way in your manifest, also using an autoscaler like the horizontal pod autoscaler. So here we're going to use minikube kubectl scale deployment. Replicas equals 3. And we see our deployment has scaled. I'm going to clear this up a little bit here. I'm going to do the get pods here and just take a look to see, make sure that we do have 3 pods running. So now let's do the opposite. Let's scale it down to just 1 pod. Let's say if there's a low number of users of your application, you could scale it down as well using the imperative command. So we're going to do the same. Minikube kubectl -- scale deployment / Nginx replicas equals 1. Then my namespace. So now let's expose our application externally. So you could use the kubectl expose command that will create a service of your workload, but we're going to do it in a declarative way. So we're going to use here doc as well. We're going to create a manifest for a service. So here, this is a service called Nginx - service, and then my namespace, and a service has a label select your app equals Nginx. So any pod that has a label app equals Nginx in the my namespace, this service will abstract from that pod and will expose port 80 from that on that pod. Well, it will expose port 880 on the service, and it'll send traffic on 880 on the service to port 80. And this is a type node port service. So this node port is available outside the cluster on a port from 30,000 to 32, I think 686 or 787. So once we have our manifest created, we'll use minikube kubectl to apply. Again, we'll use the apply command to apply this manifest. And there's a difference. You could also use the create command. The difference is that with apply, if there's any updates in the manifest, Kubernetes will apply those updates. If you use create, and if that resource or object is already created, it will reject those changes. So a service is created. Let's take a look at our service. So we'll use minikube, kubectl, get service. Dash O wide, and the my namespace. We could see that we have a service. We have node port service, which will also create a cluster IP as well for that service. So the service will expose this service internally with the virtual IP 10.109.90.131. Also, we see here that it exposes this application or the service on an outside port of 31,798. So with a service also, we want to verify as well that the lone Nginx pod is the endpoint for this service. So let's take a look at the pod and the endpoint. So do minikube, kubectl, -- get pods, and the my namespace O wide. And we can see this, we have a lone pod running on 10.244.0.7. Now let's take a look to see at the endpoints. Minikube, kubectl, -- get endpoints, -n my namespace, and we can see that we have an endpoint, and we see there's only one endpoint, and it is that same pod 10.244.0.7. So because we're running minikube, and we do have to do a port forward since I'm running minikube on a Mac. So I'm going to port forward port 7080 to 8080. So we'll send traffic from my local machine on port 7080 to the service's port 8080. So we do this with minikube, kubectl -s port forward. We want to forward the port service nginx -service and port 7080 to 8080, and in the my namespace, and we want to run it in the background. All right, so it's forwarding here. You do have to hit Control C while this port forwarder is going to run in the background. So now let's test to see if we could hit this application or this service on port 7080. So let's use curl. So if you have curl, you can use curl. HTTP localhost. And I just want to see just the first 4 lines. All right, so we have Nginx running. So that is great. So that completes the Kubernetes Essentials tutorial. So we've created a local cluster using minikube, and we've installed the prereqs, which is Docker, which has the container runtime. We've deployed an application, in this case Nginx, with the pod, also in a deployment as well. And also we've updated the application and deployment. We've scaled it up and down. We also expose the application with the service to outside the cluster. So our tutorial is finished. Thank you very much for watching. The last step is a cleanup. So we could do minikube delete -all. That will delete minikube. You can also clean up as well. Further cleanup, which is not instruction, which is brew uninstall minikube. And after that's done, you could do brew uninstall cask docker if you want to clean up Docker desktop as well. All right, thank you very much for watching. I hope you enjoyed this walkthrough.